important for us to understand the concept of gravimetric analysis. Gravimetric analysis is a primary quantitative analytical technique, meaning it is recognized as one of the most accurate methods for determining the amount of a substance. Unlike many instrumental methods, gravimetric analysis is based on direct mass measurement, making the results highly reliable and traceable. The principle of this method is straightforward. The analyte is chemically converted into a stable compound known as the waiting foam. This compound must have a definite chemical composition so that its measure can be directly related to the amount of analyte using stoichiometric calculations. For example, sulfate ions can be converted into barium sulfate, which is insoluble precipitate. After filtration, drying and baking, the original sulfate content can be accurately calculated. Similarly, chloride ions are commonly determined by precipitating them by silver chloride. Because of its high precision, gravimetric analysis is widely used for purity determination, quality control, and the preparation of certified reference material. There are three main classifications of gravimetric analysis based on how the analyte is measured. The first is precipitation gravimetry, which is the most commonly used method. Here, the analyte reacts with excitable reagent to produce an insoluble precipitate. The precipitate is then filtered, dried or ignite, and then accurately weighed. For example, sulfate ions can be precipitated as barium sulfate, allowing the original sulfate content to be calculated through stoichiometry. The second type is volatilization gravimetry. In this method, the analyte or one of its components is converted into a gas by heating. The amount of analyte is determined from the change in mass. A common example is moisture analysis, where the decrease in sample mass represents the amount of water removed. The third type is electrogravimetry, where metal ions are deposited onto an electrode using electrolysis. The increase in the electrode's mass corresponds directly to the amount of analyte present. This technique is commonly used for metals such as copper.
This is the applications of gravimetric analysis. The first one is environmental monitoring. It can help us to determine the sulfate concentration in the water samples by precipitating the barium sulfate and measure its mass. The next one is pharmaceuticals. We can figure out the purity of pharmaceutical compounds by measuring an active ingredients of the sample after the purification process, since the purity of a drug can affect its effectiveness and also safety. In terms of food and agriculture, gravimetric analysis is used to identify the moisture content by heating and weighing the samples. For example, like food products, it contains less than 2% of moisture content in potato chips to get a perfect crunch, seeds, and also any other agricultural materials. And lastly, in metallurgical industries, it helps in determining the composition of metal alloys such as the percentage of silver or gold in a sample by precipitating a known compound of the metal.
Now, let's look at the core theory of a gravimetric analysis. Gravimetric analysis is a quantitative method that determines the amount of an analyte by measuring the mass of a solid precipitate. In this experiment, sulfate ions react with barium ions to form an insoluble barium sulfate or barium sulfate precipitate. The goal is to obtain a pure precipitate with a non-chemical formula so its mass can be used to calculate the amount of sulfate. During precipitation, nucleation occurs first, where tiny particles act as center for crystal growth. To obtain larger and purer crystals, the reagent is added slowly into a dilute solution. Finally, the main steps include complete dissolution, quantitative precipitation, purification, and accurate weighing, which are essential for obtaining reliable and precise results.
Moving on to the core steps in the gravimetric analysis. To determine the sulfate concentration, first, the preliminary treatment, which is the preparation of sample solution, was performed. Here, the sulfate solution was prepared by adding hydrochloric acid. Next is the precipitation of precipitates. The matrix was heated and a dilute solution of the precipitating reagent, which is barium chloride, was slowly added to the hot solution of the sulfate. This slow, hot addition with constant stirring allows the barium ions to react with the sulfate ions, initiating the formation of a distinct white precipitate of barium sulfate. After allowing a period of digestion, the white barium sulfate precipitate was separated by filtration using Workman 41 filter paper. Then, proceed to the washing stage. The precipitate was rinsed with water to remove soluble salts and residual unbound ions. For the final stage, the precipitate is placed in a porcelain crucible for drying and igniting, where it is carefully heated at a high temperature of 900 degrees Celsius in a furnace to turn the filter paper into ash. Once cooled, the final step is weighing and calculation to determine the stable precipitate mass. Now, let's look at the specific gravimetric calculations and experimental data from the study. To find the true mass of the sulfate ion, the standard gravimetric factor formula, which uses the ratio of the atomic weight of sulfate over the formula weight of the weight barium sulfate precipitate, was applied. Using the values from the article, this means multiplying the precipitate weights by the simplified molar masses of 96 over 233 gram per mole. As shown in the experimental data, the theoretical precipitate mass of 0.70014 gram yields to a calculated theoretical sulfate mass of 0.288 gram. However, our practical laboratory balance recorded an actual weight precipitate mass of 0.8055 gram, giving a practical isolated sulfate mass of 0.3318 gram. By comparing these two final mass values, the percentage error was determined to be 15.2%.
Every step in gravimetric analysis is important to obtain accurate result. First, the sample is dissolved completely so all sulfate ions can react. Next, barium chloride is added to form an insoluble barium sulfate or barium sulfate precipitate. The precipitate is then filtered and washed to remove impurities and excess ions. The precipitate is then dried to remove moisture before weighing. Finally, the mass of the pure barium sulfate is measured and used to calculate the sulfate concentration. Skipping or performing any of the steps incorrectly may reduce the accuracy of the analysis. Gravimetric analysis is highly accurate because it measures the mass of pure precipitate directly. It also uses simple laboratory equipment, making it reliable and cost-effective method. However, it is time-consuming because it involves several steps such as filtration, washing, drying, and weighing. It also requires careful technique since losing precipitate and incomplete drying can produce inaccurate results.
To conclude everything that we have discussed in this presentation, we know that gravimetric analysis is a high-powered tool in analytical chemistry that offers high accuracy and precision in determining the quantity of substance in a sample that we use daily, like food and water. By understanding the basic principles and applications, many related workers such as scientists and lab technicians could use this method for a wide range of analytical needs.